A black hole just ate a neutron star, and the way it did it broke physics. About 1 billion light years from where you're sitting right now, a black hole roughly 9 times the mass of our sun lashed onto a neutron star, one of the densest objects in existence, and devoured it whole. That collision created a new black hole about 13 solar masses and sent shockwaves rippling through the fabric of space and time itself. Scientists picked up those ripples here on Earth back in January 2020 using LIGO. That's the Laser Interferometer Gravitational Wave Observatory, a pair of detectors separated by nearly 1,900 miles across the United States. That detection alone was historic. It was the first confident evidence we'd ever captured of a black hole swallowing a neutron star. But here's where the story takes a sharp turn nobody expected. A team of researchers at the University of Birmingham just finished a brand new analysis of those gravitational waves. And what they found is forcing astronomers to tear up a major chapter of the rulebook. For decades, the prevailing theory said that when a black hole and a neutron star orbit each other before smashing together, they should settle into a neat, nearly perfect circle. That's what the math predicted. 2 dead stars, remnants of once massive stars that burned through their fuel and collapsed, spiraling inward together in tidy, circular paths until the final crash. Clean, predictable, elegant. Except that's not what happened here. Not even close. Using a brand new waveform model, one that, for the first time ever, accounts for both orbital eccentricity and something called spin precession simultaneously, the Birmingham team reanalyzed the gravitational wave signal labeled GW200105, and they found, with greater than 99% certainty, that the orbit of this doomed pair was not circular at all. It was an elongated oval. Think less perfect ring and more squished egg, with the two objects swooping around each other in wild, spirograph-like loops right up until the moment of annihilation. That's a problem, a really exciting problem. According to the standard formation model, any eccentricity in the orbit should have been radiated away long before the system got close enough for LIGO to detect it. The gravitational waves themselves act like brakes, gradually smoothing the orbit into a circle over millions of years. So, finding a highly eccentric orbit in the final moments of this merger? That's like finding a car doing donuts in a parking lot when it was supposed to be cruising in a straight line down the highway. Patricia Schmidt, an associate professor at the University of Birmingham and a co-author on the study, called it a smoking gun signal that at least some of these binary systems must form through a completely different process than what textbooks describe. The standard story says these pairs come from 2 massive stars that are born together, live together, die together, one becoming a black hole, the other a neutron star, and then merge in isolation. But an eccentric orbit this late in the game? That points to something far messier. Gravitational tugs from nearby stars. Maybe even a third companion lurking in the system, yanking the orbit into that strange oval shape. Geraint Pradhan, another co-author and Royal Society Research Fellow at Birmingham, put it bluntly, the orbit's elliptical shape right before the merger shows this system did not evolve quietly in isolation. Something, or multiple somethings, messed with it from the outside. The team also corrected earlier estimates from the original 2021 analysis. Turns out, previous studies had underestimated the black hole's mass and overestimated the neutron star's mass because they assumed a circular orbit. When you build your analysis on a flawed assumption, your answers come out wrong. This new model fixed that. Now, what does all this mean going forward? It means we need better tools. LIGO and its European partner Virgo are powerful, but they have limits. That's where LISA comes in, the Laser Interferometer Space Antenna. It's a trio of spacecraft that will fly in a triangular formation with 2.5 million kilometer arms, trailing behind Earth as it orbits the Sun ESA, formerly greenlit construction, and it's on track for a 2035 launch. LISA will detect gravitational waves at frequencies that ground-based detectors simply cannot reach, opening up an entirely new category of cosmic collisions for us to study. This single oval orbit has cracked open a door we didn't even know was there. The universe clearly has more than one recipe for building these extreme systems, and we've only just started reading the cookbook. If this blew your mind, smash that subscribe button so you don't miss the next cosmic discovery that rewrites what we thought we knew. Drop a comment. What do you think was pulling on that orbit? A rogue star? A hidden third companion? Let's talk about it.